In the last video, I learned about evolutionary AI and swarm AI from Buzzy. Those were great technologies. Now I want to learn about transfer learning, reinforcement learning, and transfer reinforcement learning. Let's see how Buzzy can help me. Hey Buzzy, have you heard about transfer learning in artificial intelligence?
Hey Leena, yes I have. Transfer learning is a way for AI models to use knowledge from one task to improve performance on a different but related task.
That's interesting. Can you give me an example?
Sure. Let's say a student learned about cats in their biology class. Then they took a veterinary class where they learned about cats again, but with a focus on veterinary medicine for cats. The student can use their knowledge from the previous biology class to learn faster in the veterinary class about cats.
That's a great example. How can I relate it with artificial intelligence?
In AI, imagine a model that has been trained on a large data set of images of animals that can be used to recognize images of cats with high accuracy. Then, this model can be fine-tuned with a smaller data set of images of cats in different poses and environments, allowing the model to recognize cats in different contexts and improve its performance.
That's amazing! Who primarily researched transfer learning?
Stavo Bozanovsky and Andy Fulgosi primarily researched transfer learning in 1976.
Transfer learning looks similar to machine learning. Is there any difference?
Yes, of course. In conventional machine learning, the algorithms are trained directly by feeding disparate data. But in the case of transfer learning, it leverages valuable knowledge from similar tasks and previous experiences to significantly enhance the learning performance of conventional ML techniques. Basically, it is an advanced subfield of machine learning.
I see. Is transfer learning used in other fields within AI?
Absolutely! Transfer learning is widely used in fields such as computer vision, natural language processing, and speech recognition. It's particularly useful when data is limited or expensive to collect.
That's really useful. Can you show me a practical example of transfer learning?
Yes, I can. Teachable Machine is a great example of machine learning to transfer learning in action. Go to the Teachable Machine website, or you can see this interactive demo of machine learning that uses transfer learning. You can even create your own machine learning experiment without writing any code.
Now it's time for reinforcement learning. What's that all about?
It's a type of machine learning where a model learns through trial and error by receiving rewards or punishments based on the actions it takes in its environment.
That sounds interesting. Can you give me an example?
Sure. Let's say a child is trying to learn how to ride a bike. At first, they struggle to keep balance and fall off, but each time they get back on, they adjust their actions slightly and eventually they learn to balance and ride without falling.
That's like learning by trial and error, right?
Exactly! The child's actions are adjusted based on the feedback from the environment, and it's the same with a reinforcement learning model. It interacts with an environment, receives rewards or punishments for its actions, and learns a policy to maximize the cumulative reward over time.
That's really cool. Is reinforcement learning used in any particular field?
Yes, it's used in robotics, control systems, and game playing, and it's particularly useful in applications where a model needs to learn how to take actions to maximize a reward.
And what's transfer reinforcement learning?
Transfer reinforcement learning is a type of reinforcement learning where a model can use the knowledge learned from one task to improve performance on a different but related task.
That's like a student who can apply their skills from one sport to another, right?
Exactly! Please remember the previous example of reinforcement learning and watch this. Imagine a baby learning to ride a tricycle in his early days. That time he does not know how to balance because in a tricycle no balance is required. He only has to paddle and keep the handle steady. And later when he learns to ride a bicycle or bike, he can apply his previous learned skill and can learn to balance. In this example, can you relate anything with transfer learning?
Yes. Now he is transferring the skills learned in tricycle riding and bicycle riding with reinforcement learning. That's really fascinating.
This is how transfer reinforcement learning, or TRL in short, works. Just like a student who learns skills in soccer can apply them to hockey or ice hockey, a model trained on a task like playing chess can improve its performance on other board games like checkers or drafts.
That's really impressive. Thanks for explaining all of this, Buzzy. I learned a lot today about TL, RL, and TRL.
No problem, Leena. I'm always happy to share my knowledge with you. There is also another related term called deep reinforcement learning, or DRL, which is a subfield of machine learning that combines reinforcement learning, RL, and deep learning. This is a more advanced topic and is out of scope of this video series for basics of artificial intelligence.
How are these different types of AI models trained and how to learn more about them?
Mainly these types of models are trained with cloud computing systems like Google Cloud. Google has a free course on X platform called Google Cloud Computing Foundations, Data, ML, and AI in Google Cloud. This introductory course will teach you all about AI and big data in Google Cloud. You can find the link inside the description and first pinned comment.
Great, I'll check that out. Is there anything else you'd like to say to your viewers?
Just one more thing. If you're interested in learning about other advanced AI technologies in simple terms, there's a playlist that's worth checking out.
Thanks, Buzzy. That's all for today. If you enjoyed today's topic, please don't forget to hit the like button and subscribe to this channel. Your thoughts in the comment box would be greatly appreciated.